In this video, we look at a program for binary tree. We will create a binary tree and also we will see traversals on binary tree. So for creating a binary tree, we need queue data structure where we will be storing the addresses of the nodes. So already we have written a C language program for queue using array. So I will use that same code in my new project. So I will copy this. There's a structure for queue and create function is there, enqueue and dequeue is also there. So I will take all these and display. I don't need display function. Okay, this is enough. I will copy this one. Then I'll start a new project for trees. New project. I'll give the name as a tree and it's a C language project. So yes, create it. Yeah, project is created. Now here I will add a header file where I will write down the functions that are required for queue. So I will say new and file and let it be a header file. Yes, it's a header file and the header file name I will call it as queue. So queue.h is created and inside this I will paste everything. So I have create function and queue and dequeue functions. These functions are for circular queue so that I can use that array circularly. Then here I need more functions, so I will write on them. That is empty function I will write on. It should take a queue as a parameter, that is struct queue, and this is queue, and it's called by value. It should check if front is equals to rear. So queue dot front, if it is equal to queue dot rear, then it should return whatever the result of this equality operator, it should return. If it is true, it will return true, otherwise it will return false. So this is a queue available. Now one important thing is this queue is going to store addresses of tree nodes, so not integer type data. So here itself I will define a structure for node. This is a tree node, so I can say node or tree node, anything. The members of this one is struct node, that is L child, and integer data, and struct node R child. This is a structure for a node. I have to modify this queue so that it can store these nodes. So this is a node type of pointer. So this is a double pointer I should take. Means this pointer is for array and this is for pointer of type node. It's going to store pointer of type nodes. Then this queue structure, then here. When we are creating an array, it is not integer type pointer. It's a node type pointer to a pointer. That is double pointer. I'll hide this panel. Then the number of elements are size and it should have size of node type of pointers. So it's an array of pointers. So the array is created like this dynamically from heap. Then enqueue function, I have to modify it. Element it should insert is node type of pointer. Then dequeue should return me node type of pointer. Yes, and this x should also be node type of pointer and it should be initially null. It's not -1, it is null. So I have done sufficient changes that are useful for making this queue useful for tree. Now let us go to the main function. Now outside the main function I will create a pointer of type node as a global variable so that it can be accessed anywhere, so it's easy for accessing. Root, and root is initially null. Now we will see create function. Create. So as I have explained you, the same way I will write on the code here. So I need node pointers, so like this temporary pointers like p and t that I was using. Then also I need a variable for reading the data. Then I should also create a queue data structure, queue. Then I should create a queue. So for creating a queue I should send the size. So I will take the size as 100, so that is sufficient for queue. and I should also send q as a parameter, that is by address. First thing is I should know what is the value in a root. Enter root value. Then scanf percentile d, take the value in a variable x. Then create a root node. Root assign struct node pointer malloc size of struct node. A node will be created, then roots data should be set as x and roots lchild or roots rchild assign null. So the node is ready. Then I should insert this root in queue. So queue. Root is enqueue in a queue. Now, as I have shown you, I should have a while loop while not is empty queue. This is called by value, so just queue. Then to a pointer p, I should dequeue from the queue and take a pointer. So for every node, take a node from the queue. I should ask for left child and right child. Take the left child value and the right child value. If it is not -1, then I should insert it. So I will write on that procedure. Printf enter left child. Then scanf percentile d, take data in x. And if x is not equal to -1. So as I said that if it is -1, we assume that the value is not there. X is not equal to -1, then we will create a node t assign. I should create a node so that code is here. I will copy it and paste it here. So the node is created. Then t's data should be set as x and t's lchild as well as t's rchild should be set as null because this will be inserted as a leaf node. Then t's lchild, that is left child, should be set as t. And also this new node I should insert it in a queue. Ampersand q, this t is inserted in a queue. Now as I have done for left child, the same thing should be done for the right child also. So copy this code and paste it here. Now instead of saying left child, just say right child, enter right child. And this p is right child. That's all. Everything is same. So this is a little lengthy function for creating a tree. And root is a global variable, so it's accessible everywhere. So I can directly call create function. Now here inside main function, I will simply call create function, which should create a tree. Then after that, for displaying, I should have a function for pre-order traversal, and to that I will send root, and I will write a recursive function here, void pre-order struct node star p, and if p, this is the simple code that we have already seen, printf percentile d with some space, p's data, print data, then call pre-order upon p's left child and call pre-order upon p's rchild. That's all. Now after creation of a tree, I am calling pre-order function. So main is having just two calls to functions create and pre-order. And one thing on the top, I should include the header file, that is q.h I have included. That's all. Now let us compile and run the program. Oops, I got an error. Redefinition of create. We have written a function called create for q. So I will change this create function. This is a tree create, so I will call it as tree create function. And inside the main function also I will call it as tree create function. Now let us run this. Now the program is running. Enter root. So root value is 10. Now root value, is it having value? Left child? Yes, 20. Is it having right child? Yes, 30. Then enter left child. Who's left child? Oh, I missed this one. I should give a message. I'll stop this program and I will show here that is whose left child we want to find out. So enter left child of percentile D. So here I will print P's data so that I can know whose left child we are asking. And even here I should make a change when I am asking for the left child of percentile D. So I can know whose left child and right childs are being asked. Now let us run the program. It's asking for the root value. So root value is 10. Then enter left child 20, enter right child 30, enter left child of 20, that is 40, then right child is 50, left child of 30 is 60, right child is 70. Then after that I don't have any nodes, so minus 1 I am entering, so it will not do anything. It will not create any nodes. Now this is the pre-order traversal. You can see this 10, 20, 40 and 50, 30, 60, 70. These are coming on the right hand side. These are coming on left hand side. 10 is root. So this is the pre-order traversal. That's it. So I will include one more function like this for the pre-order. So I will write two more functions and that is for in order and post order. Copy this. Instead of pre-order, I will just name it as in order and this printf should be in between. So cut this one and paste it here. Now instead of pre-order, this is in order. Now this is post order, post, and printf should not be there. And this is post order function. This is post order function. Now at the end I should print the value yes. Now after pre-order I'll give a new line and then print post order, new line, then this is post order. I will call the function that is post order. Post order, O is small, passing root. Now let us run and check. I'll give only few nodes. Root value is 10, okay. Left child is 20, right child is 30. Then after that I don't have any nodes. Minus 1, minus 1, then minus 1, minus 1. See, pre-order is 10, 20, 30 and post-order is 20, 30, 10. It's perfect. So that's all in this video. We have seen how to create a tree. It was quite lengthy because I have to prepare queue also that is useful for creation of a tree. That's all in this video.